talk today about something called an identity metasystem. It's a little bit of an esoteric concept, but it's important to understand if we're going to get identity right on the internet. This is no surprise to most people. The internet was created without an identity layer. Actually, it does have an identity layer, but it's about IP addresses and services, not about people. The result is that we end up with identity systems that look like this. Amazon creates an identity system for themselves. We all get accounts there, and then we get an account at Google and everywhere else, right? So we end up with hundreds of accounts. So there's no center. We're not in the center of this. We're just kind of sitting in all of these places. This is very different from how identity works in the physical world. If I go down to the pharmacist, pick up a prescription, and they need to know I'm over 18 in order to fill my prescription, what I do is I show them my driver's license. Does that work the same way in South Africa? You use driver's license to prove your age? Maybe something? Yeah. What's going on here? Why does this work? This works because we trust the Driver's License Bureau to have done a reasonably good job of identity proofing, and it's packaged in a way that's easy to tell it hasn't been tampered with. It has a sophisticated biometric device on it called a picture, and I can hand this to people and they can look at it and say, yeah, that's you, that's your birthday. They do the math, they know how old I am. And what's even more amazing is I can start a business tomorrow. I do not have to get permission of the Driver's License Bureau to start checking people's driver's licenses. I don't have to do any API integrations. I don't have to have any kind of business relationship, any technical relationship, nothing. I just decide I want to do it and I start doing it. And it works because people carry their driver's license around in their wallet and are free to show it to anybody they like for any purpose they want. Now, let's talk about how this could happen online. Because the problem is these kind of credentials have been around for hundreds of years. We use them in the physical world in order to support ad hoc workflows, like me starting a business and deciding I need to check people's driver's licenses. There's no way to do that online. So what we do now is we build intermediaries, and everybody has an app for that, right? Oh, I'm going to create an app that will certify coffee growers, and now I just have to get all the coffee growers and all the coffee buyers to use my app. Well, that's not how it works in the physical world. So what happens if we're using verifiable credentials? Verifiable credentials is a W3C standard, basically a signed JSON document. My employer can give me a credential, digital, that I hold in a digital wallet, and that could have my employment history on it. It could have my salary. It could have my current position. Anything I want. Now let's say I head down to the bank and I want to get a loan. And they say, well, we need to know that you're employed and that you make over $70,000 a year in order to give you this loan. I can use that credential to prove to the bank just those two facts. I'm employed and I make over $70,000 a year. So they've decided what they need to know. I've decided what I'm going to tell them, and I can prove that to them cryptographically without anybody being in the middle of that. Because they don't have to talk to my employer in order to know that that credential is real and hasn't been tampered with. So there's 4 checks that a verifier does when they receive a proof. They check who issued the credential. They want to know, was it issued to the person who presented the proof? They want to know, has the data in the proof been changed? And they want to know, has the issuer revoked the credential? Those are the things the verifier checks. And all of those can be checked without having to talk to the issuer of the credential, just like in the physical world. Now, this system has some important decentralized properties. First of all, it is contextual, meaning that anybody can create any credential for any identity system they want to build. Whatever your workflow is, whatever you need to support, you just decide what credentials you want to issue and you can do that. Like we talked about, verifiers don't have to talk to the issuer. Verifiers can make their own trust decisions. They can decide whether they're willing to accept my employer's credential or not, or whether they want additional data, as is their right. And importantly, people, owners, identity owners, get to decide what credentials they're going to carry around and which credentials they're going to use to prove things to people. So everybody gets to make their own decisions in this world about about what they're going to trust and what they're going to do in order to create trust. This creates something which I call multi-source identity. This is how identity works in the physical world. You don't just have one big identity document. You don't have one universal identifier that has all of your attributes in it. Instead, you have a multitude of credentials that you mix and match depending on the situation. Now, there's some core technologies that make this work. First of all, something called, I'd said that you're going to present this. That means that the issuer has to be able to talk to the holder needs to be able to talk to the verifier. This happens using a peer-to-peer system of agents. These agents talk to each other, create a trust relationship with each other, and that's how credentials are exchanged. This happens using something called a decentralized identifier. This is another W3C standard that is used in order to create self-sovereign identities. Okay. And finally, there's a distributed ledger. Distributed ledger is not used for very much, but the things it is used for are vitally important. Remember, the verifier doesn't have to talk to the issuer in order to know whether or not the credential is real. That's what the ledger provides. The ledger provides a common place that everybody can use to see who the issuers are and what credentials they're issuing. Now, to put those four technologies in a stack, we can kind of look at it like this. So we have DIDs on a public blockchain. That's the core foundational piece of this. We have agent-to-agent relationships. This is a peer-to-peer network, which aids in scaling. Peer-to-peer networks scale very well. Right? So you don't have to scale the blockchain to be able to hold everybody's data and be able to support everybody talking. The only thing the blockchain has is information about the credential issuers. Most of the work happens in these peer-to-peer agents, so it can scale to trillions of transactions. These two layers together form something we could call cryptographic trust, because everything that's happening here is a protocol and cryptography, making sure that everything is okay. On top of that, we put the credential exchange, what we've been talking about. And on top of that, we have governance. And these things we can think of as human trust. Now, what do I mean by governance? Let me give you an example. My day job, I work at a university. I'm in the CIO's office as an enterprise architect. Brigham Young University, we are credentialed by the Northwest Association of Colleges and Universities. That's a process that's been going on for 100 years. They have a whole process about what they expect when a university gets credentialed and what those credentials say and how those credentials are revoked. And if you have an argument about those credentials, how you adjudicate that. That's governance. So this human layer has to have governance for every specific context. So everybody can build their own context, their own contextual identity system on top of the underlying cryptographic layer. This guy is Kim Cameron. He's Microsoft's chief identity architect, has been for 20 years or so. Kim is a visitor from the future. What I mean by that is in 2005, he wrote a paper called The Laws of Identity. And I'm going to talk a little bit about it, but if you want to really understand what he was saying, go look at the paper. Okay, Kim Cameron, Laws of Identity, you'll find it. What I mean when I say he was a visitor from the future is he was saying things in 2005 that I and other identity professionals are only really starting to understand now. So what did Kim say? A little bit of an eye chart. But basically what he said is that we need a meta system for identity, which has an encapsulating protocol where information about people can be presented in a privacy-preserving way. It can't be a monolith. It can't be a single identity system. Rather, it has to be a foundation upon which multiple identity systems can be built. And he says it needs to be polycentric and polymorphic. I'll tell you what he means by that in a second. So key ideas, right? Single technical framework, supporting different identity contexts. Each context flourishes on top of this identity metasystem. And the information is used according to some kind of governance. When he says polycentric, that was his 2005 word for decentralized. So no single authority in the system who's saying how all of this works. When he says polymorphic, he means that you need to be able to support multiple contexts. You can't just create one system and hope that every way that people want to do identity around the world is going to fit into it. You have to support them building their own context on top of it. Now, my contention is that what we're building at Sovrin is this identity metasystem, this foundational layer upon which multiple identity systems can be created. I call it a global, decentralized, open public utility for digital identity. Lots of words there, but they're all important, right? It's global, meaning everybody can use it. It's around the world. Decentralized, no single authority. It's open, all the code is open source, but moreover, all of the processes are open. It's public. Anybody can use it, right? It's not just a certain group of people. And it's a utility, meaning it's this meta system upon which everything can get built. Now, going back to this is the same diagram I had before, but notice that I've relabeled these two boxes. Where it used to say cryptographic trust and human trust, it now says identity metasystem and context-specific identity system. So Sovrin is this blue layer providing a way to do all of the credential exchange. And then individual identity contexts, what do I mean by that? It's a little abstract, can build something on top of that. So I mentioned university accreditation. That could be one of these identity contexts. You want to know if your coffee beans are certified organic. That whole supply chain thing can be one of these context-specific identity systems. A driver's license, business registration. There are literally hundreds of thousands of identity contexts that humans have developed in the course of supporting workflows in the various activities that we support. They all have to be able to be fit on top of this. Now, Kim followed up his discussion of an identity metasystem with what he called the laws of identity. And I think when you look at these, you're going to see that a lot of these fit with the same kind of things that we want from blockchain systems. So his first law was user consent and control, meaning that the user has to be part of the system. They have to be part of the interaction. Okay. So this is the same verifiable credential flow I showed you earlier. It's changed a little bit, but we've got the credential issuer on the left, we've got the identity owner in the middle, and we've got the identity verifier on the right. Okay. Notice that the human is sitting there making choices, deciding what credentials to present. The user is consenting to all of the information that's shared and controlling what information is shared. Second law, minimal disclosure for constrained use. So remember when I talked about using my employment credential to prove to the bank that I'm employed and make over $70,000 a year? That's minimal disclosure. I might have a credential that has all kinds of information. I only need to reveal to the bank exactly the information that they need. And yet they can verify that it was true, it came out of the document, it came from a certain place, all of the things they need to know. Justifiable parties, this is an interesting one, because usually what we do in identity systems is we build an intermediary. I'll bet you 90% of the business decks that venture capitalists see are about building intermediaries to link workflows up. Oh, I've got an app for coffee growers. I've got an app for, you name it, we build an app for it. And now the app is sitting in the middle of everything. In this flow that I showed you just a minute ago, the only parties to this credential flow are the employer, the identity owner, and the bank. Only the parties that need to be part of this transaction see the data for this transaction. Directed identity, this is interesting. So Kim talks about omnidirectional and unidirectional identifiers. Another one of those things that when he said it, I had no idea what he was saying. It turns out that we do this exact same thing. Remember I said that you have these agents, and these agents are talking to each other. Well, that happens because your agent and your employer's agent have exchanged one of these decentralized identifiers. And by doing that, because decentralized identifiers are cryptographically linked, you've created a specific channel, a cryptographic channel between you and your employer. You do the same thing with the bank, different did. In other words, these are unidirectional identifiers. You gave your employer a different identifier than you gave your bank. Why is that important? Because that way, your bank and your employer can't correlate data about you behind your back. All of the data harvesting that happens is happening with correlation, right? Correlatable identifiers. Your cell phone number is probably the most correlatable identifier that you have because people hold on to them now. Right? And we give up our cell phone number to everybody. Pluralism of operators and technologies. Okay. So, going back to this diagram, what this means is just what we said about this diagram. Right? That everybody who's building a context-specific identity system can make their own choices about what credentials are important and how those credentials are going to get used. That's what we mean by pluralism, that there's multiple ways that you can use this, not just one way. Now, it's interesting because remember I said that these agent-to-agent connections formed a cryptographic channel? So once you've got people using this, and people have agents, we now have a system of peer-to-peer cryptographic communication channels that everybody has access to. So not only can we do credential exchange on it, but we could do all kinds of other things on top of it as well. That's if you're thinking out in the future, that's one way to think about how this all works. Okay. Sixth law was human integration. The human has to be part of the workflow. That was one of Kim's laws. Okay? And we can see from this diagram that human is sitting right in the middle. Human is integrated into the workflow. Last law, consistent experience across contexts. Now, he didn't mean one app. And in fact, I suspect there will be multiple wallets that people build for using Sovrin. But there is a consistent user experience. Think about email. You can use multiple email apps, but there's a consistent user experience. You know what an email address is, you know what the subject is, you know how to type things in the body, you know how to put in attachments. No matter what email client you're using, you ask yourself, okay, how do I add an attachment in this client? And then, because you know about attachments. Same thing here. You're going to understand relationships and you're going to understand credentials. So an identity wallet is not like a cryptocurrency wallet. It's not about tokens and currencies and addresses. It's about relationships and credentials. But all of the wallets will have that consistent experience. The important part of that is that now people, when they do something, they understand what's going on instead of every app being different and every user flow being different and never really knowing exactly what's happening with your data. This will probably look a lot like something, an app on your iPhone. But it'll be like the browser. Rather than using it with a single company, you'll use it with multiple parties. You'll have relationships with multiple parties. I won't go through this. This is in the paper. You can go read it. But basically, he's just saying that this consistent user experience is what provides us with the user experience that's needed in order to preserve privacy. And on the subject of privacy, Kim does not talk about privacy specifically in his 7 laws. But it is something that emerges from the 7 laws. And privacy is important. Because remember we talked about user control? If you don't have privacy, you do not have control. Control and privacy are inseparably linked. Without privacy, there is no control. So an identity metasystem has to have as much privacy as we can figure out how to build into it. I talked about minimal disclosure. That's one way that you ensure privacy. I talked about non-correlatable identifiers. That's another way that you create privacy. So privacy is a very important principle of this metasystem. So that's me. I tweet at Windley. I blog at windley.com. I have an unusual name and I'm an early adopter, so I almost always get my name as an account. I pity the poor John Smiths out there. Anyway, that's where you can find me. There is an article on identity metasystem on my blog, and it links to Kim's paper if you're going to try find it. So, happy to answer questions.
Any questions from the audience?
Hi, thanks for the talk. I'd like to know how far is the standardization process of the proofs or attestations?
Yeah, good question. So DIDs is a W3C standard, so decentralized identifiers. Verifiable credentials, the format is a W3C standard. What needs to happen next is we need a standard for credential exchange. Right? That's not there yet, but we are working hard on credential exchange and the agent-to-agent protocol, and that's where we're going with that, is standardizing all of that, because everybody has to be able to play in this. You know, it's not a single system with a single app.
Thank you so much, Atish.
Hi, Philip. Thank you for the presentation. It was very interesting. I'd never come across the laws of identity before, so thank you for that. Just tying on to the last point you were making about trying to incorporate as much privacy as possible into such a system. Now, looking at Sovrin's architecture, I know that the issue is that, or effectively the stewards that are allowed to actually write or issue claims onto the Sovrin Network today would be, you know, our South African Department of Home Affairs or a bank or some regulated institution.
Yep.
Now, in liberal democracies, this is okay. But what I'm wondering about is that, has Sovrin, do you have any views with regards to how to create truly self-sovereign identity for people that actually live in like authoritarian or totalitarian regimes where the government would ultimately revoke your passports or your ID documents at will?
So that's a good question, and it's a hard one. You started off talking about the ledger and stewards, so it's important to just mention what goes on the ledger. What's on the ledger are the unidirectional identifiers, the public DIDs for credential issuers, credential definitions that say what a credential is, and that includes a schema, and a revocation registry so that you can prove that your credential hasn't been revoked. But none of the credential exchange depends on the ledger. Credential verification depends on it, but credential exchange does not. And so since these are peer-to-peer relationships, as long as people have access to the app, or the apps, right, there could be multiple wallets, as long as they have access to a sovereign app, they could create relationships with other people, exchange decentralized identifiers, and have a cryptographic communication channel based on that without the ledger being even available. Right? So if the government, for example, blocked the ledger, then you could get by with that. If they block the apps, then, you know, I guess it's all open source and all open protocols, so maybe they could build something internally. It's really hard to get around how you can just, you know, completely get away from that. But, you know, given that people could get apps and that they could exchange decentralized identifiers, I think it would still work very well. The other thing that you mentioned is, you know, you can have things revoked, and that is true. And this is a multi-source identity system. This system, no system like this, can keep the government from revoking your passport. If they revoke your passport, they're going to revoke your passport. But they're authoritative just over that passport. You could have lots of other documents in your identity system that other people may be willing to accept for various purposes. Right? So the fact that you lost your passport doesn't affect all of the other things that are in your digital wallet. And that's an important idea. That's what we mean when we say multi-source, is that you're not dependent on just a single identity or, you know, a government identity system that, yeah, they could take it away from you and you just lose it.
We have time for only one last question. I saw some other hands up. Philip, will you be around in the break?
I am, and in fact, I was going to say, I have a demo, a little old, but a demo working, it's actually a video, because you never demo anything live, right? But I've got a video that shows all of this working. If you're interested in that, just find me in a break, and I'm happy to show it to you.
Fantastic. Last question.
Perhaps you can find someone else, because you answered the question about revocation.
That's perfect. That's perfect.
Yeah, revocation is an important property. Kim actually built a system that followed these laws called info cards. If you Google info cards, you'll find it. It wasn't accepted for a couple of reasons. One reason was it was coming, people saw it as coming from Microsoft, right? It wasn't, it was an open standard, but nevertheless. And the other problem was it didn't have great revocation abilities without actually talking to the verifier, which causes privacy problems. So I think we've got that one licked now.
Philip, thank you so much for coming all the way to South
Thank
Africa.
you.